Yeah, actually, this is the Ministry of Education. You just see that, and Ministry of Education, Government of India initiative. So they have already given the opportunity to IIT Kharagpur to lead in this field. So logic design and computer organization virtual lab will cover both of this course here. Okay, so for lab session, so you just continue. We'll make up. So here will be the list of experiments also there, experiments what we have to complete it, everything is mapped here. Okay, so you just remember few experiment you have to done you by yourself by coding also guide you, just like Quine McCloskey's algorithm. You see the last algorithm, Quine McCloskey algorithm.
Yes, sir.
Yeah,
Yes, sir.
yeah, just your anyone response, just I can interact that you are actually listening me. So Quine McCloskey's algorithm you have to implement using Python, C or Java, any programming language, up to 5 variable. Okay,
Okay, sir.
I will conduct, that means I will call any one of you anytime and share the screen, and I will give you the input. You will give the input in front of me and it will run. I will check and then code. So implement your code yourself. Try to understand this one. Quine McCloskey's algorithm and Karnaugh map. These two parts you have to do by programmatically using any program, C program, C++, Python, Java. Programming language does not matter for us, so you just implement it. Okay. Last two problem, you start by yourself up to 5 variables. For Karnaugh map, you go for 4 variables up to sufficient. Don't go for 5 variables because this time we will not get sufficient time. 5 variables is some complex for Karnaugh. So Karnaugh up to 4 variable you consider, and Coin McCloskey up to 5 variable. These two you have to implement immediately from your home, your computer yourself, and I will check it after end of the course. We will show you Ripple Career. I think one of my teaching assistant, Mr. Anandan Mondal, will explain the Ripple Career to implement the software. The software also mentioned here. You will find the software guidance. Everything is given here. So all the guidelines is given here. Just 1 minute. Was waiting my lobby. Mahbub, did you join? Mahbub. Okay. Anandan. Anandan.
Hello. Hello.
Yeah, Anandan, did you get me?
Hello. Hello,
Yes.
sir.
One thing, you just convey the link to the showroom and also tell the Mahabub to join again.
Okay, sir.
Because anyhow in the lobby, but not bypassed, I think the lobby, but still he didn't join. So inform him again. So student, you see the Linux jar versions are there and Windows also there. We are following Windows versions here. So you can follow both of these, no problem. Okay. And also in this workshop, you will find some manuals also there. Lab manuals, everything are there this time. Okay. Just you have to implement
Yeah,
using all
yeah.
these things.
I will accept.
So all these informations already stipulated here. So you today he will explain. First listen all the explain. I think you'll find. So recall carry header will implement. You have to implement these two: carry, look, ahead header, and wall history header. Wall history header we didn't explain. Try to understand from the your book. If you're unable to get it, you can respond. So we will discuss it again. Okay. So first experiment today we will show recall carry header with some basic logic gates introduction. We will directly ripple creator, then you implement these two. Same thing, synthesis of flip-flops will show, and maybe one counter or register implementation. You have to do all these things. So combinational multiplier also you have to implement. Got the point? Anindon?
Hello.
You can start. Now I have disconnected. You start it. Share your content and accordingly you start discussing the logic circuit.
Okay. So this is the simulator page. I think Sir has already told you to download and install. Hello. Hello. Am I audible?
Yeah, audible. You continue.
Okay, Sarah has already told you to download the simulator from this particular website. And one thing that I need to tell you that you need Java installed in your laptop to run it. And in Windows, you will just need to double click on this particular jar file to run it. And in Linux, you have to give this particular code to run it. So here I am doing this in Linux. CD desktop. Okay. So this is the whole breadboard simulator. In this simulator, we can actually build different types of logic circuits, and then we can also simulate it and see its results. So in this case, at first we will show how to simulate a simple basic AND gate. So here you will see that in the right hand there is a palette, and there are different types of components available, like the circuits and levels, logic gates, input outputs, adders, sequential circuits, other components. So we will start with the very simple basic logic gate, which is an AND gate. So I'm going to zoom this little bit.
Hello, sir. Hello.
So
Yes, sir. How can I run it on Mac?
Mac, I don't know. I think they have only given here, I think on Linux and Windows for.
Okay, just
So
tell me what's the question. Again, repeat it.
sir, how to run it on Mac?
Oh, sir, Windows and Linux versions are only given. Okay. At performance, they have not implemented the Mac version, so try to incorporate yourself with this Windows or Linux version only. Okay.
Yes, sir. Sir, can we run it on a virtual machine?
Yes.
Can we run it on virtual machine?
You try it because I didn't try it. You can try. It's possible. If virtually you can implement any Linux or Windows system in your computer, it can be done. Only the jar file is required to run, or the system should have the Java. In a virtual machine also, you should have the Java.
Okay, sir. Okay, sir. Thank you.
Okay, so we are going to simulate a simple AND gate. So you click here and drag it here. Okay, and now since the AND gate is present here, so you have to now connect it with input and output. So for this, for input, you have to connect here. Just a minute. For input and output display, for input you use bit switch. So you click one bit switch here, and you place another bit switch here. Okay, and to check the output, we need bit display. So this is the bit display, and now you have to just connect them. So for connect, you go here in the selection pane and use connection. Connect, connect. Again you connect, connect, and okay. So this is a simple AND gate, and now I want to check whether it is working or not. So for an AND gate, we know that if the both our inputs are 0, here by default the inputs are actually logic 0. So if we are now going to simulate it, the output will obviously be 0. So this is a simulate button. Simulate and it will remain 0. So we now want to test it with other inputs. For example, we want to check it with both inputs at 1. So double click here. If you double click it, it becomes logic 1. Again you double click, it becomes logic 1. And you now simulate this, your output will be 1. Okay. Okay.
Sir, could you repeat how we change the input, sir?
Here, this input. Hello. If you this input, just double click.
Okay. Okay, sir.
Just double click. Just double click. And if you simulate, it will become 0, 0, 1. So 0. So you double click, it becomes 1. And now simulate, it becomes, it seems is 1 as output. Okay. So suppose I now want to label it. So suppose this is my input A and this is my input B. So here there is a label option. Click, paste. Sorry. Label, suppose label. So to how to rename this? So you go to this box and type suppose A, and then click on label. So this will change the label. So again select this, go to this box, type B, change the label, it will be label. Suppose similarly if you want to call this as output, go here, check this as output, then just label it and this will be output. And you can actually drag this, click, drag. So this box is actually you can drag, okay, like this. Now you want to save this file. So for saving, when you click on the save, it will ask you for your roll number and name. So enter your name. So I am giving my name. Enter. So I am saving this. The extension is actually .logic. Okay, so please remember this. So just example .logic. So example .logic. And once we have saved it, what it can, the purpose of saving your name and roll number is that after you have saved your file, if you go to this particular option, show user ID, and click it, you will see that your name and roll number is shown here in this box. Okay, fine. So now suppose create a simple half adder. Okay, so I'm going to select the whole pan and delete it. So for an half adder circuit, we need an AND gate and an XOR gate, right? So again, you perform the same procedure like an AND gate and an XOR gate, and you need two inputs here. Again, place it here, and then you also need to check both the outputs. So output here, okay, and you just have to connect them now. And B, XOR B, for example, connect it. So I mean, I think you understand how this basic connection works. And one thing I like to say is that you can copy one particular circuit. So suppose you are building something large and you need to copy this particular part. All you have to do is go to selection, click on the selection button, and then select this entire area. Then click on the clone tool, and then you start dragging from this position. So this is how you can clone a particular circuit. So if you need to clone a particular circuit, you can do this. Okay.
Student, if any steps you have some confusion, you interrupt and ask him. But when he's already covered, then you are asking, then it will be very difficult for him to conduct the classes. So at the moment, whenever he explained any step, if any doubts, please raise your voice. Okay. There is a hand gesture also there. You raise your hand. Arindon, you just take care that whether any students they are raising their hands or not, or they are showing any hands or not. Okay. So students, up to this, any confusion? Any confusion?
Sir, can you show that clone tool again?
Okay.
Okay, that's good. Show it.
Suppose I want to clone this whole circuit. Okay. So what you have to do, first go to this selection tool. This is the first option in this palette. Okay. Go click on it, selection. Then here the circuit you want to clone, you have to select the whole circuit. So click and then you drag your mouse cursor like this. So this is how you have selected this whole circuit. Now you want to clone. Now go to the clone tool. Click. Once you have clicked, now do not click anywhere else. Click on any part of this circuit. Click, don't release your mouse. Just drag. Then release your mouse. Okay? Is it okay?
Thank you, sir. Yeah, thank you, sir.
Okay.
Again, you can join these two circuits with some to show how to join. Suppose we have to join this circuit.
So joining is actually done by normal connections here. Nothing, I mean, different. I mean,
Just
if
show
we
them,
want
show
to,
them. Otherwise, after cloning, they will ask whether they are joining or not. Show more details as possible and little bit go.
okay, just a minute, sir. One thing is that since this, so this is the cloning option that is available here, and one thing is that 1 minute. I have to open some example. Operator logic, single effacer. Suppose you actually have to build some larger circuits. Okay, so in that case, in this software they are providing a lot of circuits already available. For example, you don't have to build any half adder here. You can see that half adder, full adders, or even ripple carry adder, they are all available as a component here. So we can also use them and to build some larger circuits. Now one thing I like to say is that this particular size of this whole background canvas or whatever it is called is pretty limited. I mean, this is the whole canvas, so you have to use your space accordingly. I mean, you cannot just infinitely increase or decrease this space. Okay, so suppose we want to use one half adder circuit. So for example, we can build a full adder using half adder, and for that you will have to, suppose we want to use the half adder that are provided here. So this is one of the example of the half adder circuit that is provided here, and you will find that although there are 4 input pins on this side as well as 4 output pins on this side, actually only some of them works but not the others. So for example, if you want to use half adder, you have to use this combination, otherwise it will not work. Okay, for example, this is my input A, input B, and this is my output sum, and this is my output carry, and this is the half adder. The half adder is available here, so if you just click and paste it here, this is the half adder circuit. So in this case, in half adder, if you want to use it properly, so in that case we have to use these 2 inputs pins and the side 2 output pins, because if you use these pins, this will not work. I mean, they have not provided any details about why it works or not, but so far we have tried it and found that only this pin configuration working. So if you are building anything using half adder, so please remember this thing. Okay, and for example, you can just simulate and find out what is happening here. So in this half adder, so both the inputs are 1, so my sum is 0 and the carry output is 1. So it is working correctly in this case. And for another example that I would like to show you is that building one particular full adder using half adder. So this is example of using or maybe cloning or using two half adders as well as connecting them. So in this case we are building a full adder using two half adders. So you can see that the first half adder is placed here, the second half adder we have placed here, and so our inputs are A and B here connected. I am connecting it with both the side pins, as well as this output, as we previously seen that this is the sum. So this output goes to the input of the second half adder, and then in here this is the C input, and this is obviously directly connected with the second half adder, and this output is obviously the sum, as well as these two are connected with an OR gate. So to show you the carry output. So if you want to simulate this circuit, say suppose 0 0 0, you will see that both sum and carry are 0. So any one is 1, sum is 1, and so this time the carry is 1, sum is 0. So this is carry and sum, they are all 1. So I think you can build a ripple carry adder, a 4-bit ripple carry adder, by cascading the full adders. So for that you will have to okay. So in a simple ripple carry adder, so if you want to build a ripple carry adder, you will have to use 4 full adders. So for that purpose, you will have to use this particular pin configuration. So you have full adders available here, so use them, drag them on the board, and you connect it with their inputs, and then you subsequently connect the outputs. But make sure that when you are connecting, this particular input should not be used, because if you use this input it will not work. And for sum and carry, the convention is similar to half adders. So if you want to use and build any ripple carry adder, so you have to use 4 instances of this full adder, and then you can continue. Okay. So hello sir.
Yes,
Hello.
audible. Yes,
Sir?
audible.
Sir, sir, for creating ripple carry adders, sir, I think they can do this now. I mean, I have shown
At
in
least
them.
you show 2 bits, you showed carry propagate. At least you show for 2 bit at least. Is a 1 bit full adder. So you make another full adder cascading and add it and show them it's working.
Okay, so this is the clone tool. Okay.
And also in the part of web, how to show in the result in the web.
So
You
that part, I mean,
try
it is still pretty new to us. So I mean, we will cover it in the next day.
Sir,
Okay,
one
sir.
doubt,
Sure,
sir.
sure.
So one doubt.
Yes, Prajota, what is your doubt?
Sir, actually you said that the inputs can come in the extreme pins only, sir. Sir, in that case, what is happening in case of the full adder, sir? Because one of the inputs is in one of the middle pins also.
I am not getting your point. Please repeat it again.
Sir, you said that the inputs for the
Yes.
adders will only be happening on the extreme pins. The middle pins give invalid output. Sir, in that case,
Middle pin means what you are telling here. Middle pin. Extreme end.
yes, sir. Extreme end, like in the half adder diagram, sir, we were told that input can be done on the extreme ends only. We cannot use the middle two terminals, sir.
Arindan, please show the half adder symbol.
Okay.
Did you get this question?
Sir, I think. Okay. No, sir.
Prajata, yeah, based on your question, it is the half adder design that they are given in this simulator.
Yes, sir. Yes,
They
sir.
have some certain limitations in the input and output pins.
Yes,
So
sir.
that documentation is not properly given to us.
Yeah.
or we are not
Now
following-
problem is that Saurabh, they are mentioning that here
Yeah,
4 pin
so-
is there. So why extreme?
yes,
Actually,
sir.
half
I'm
adder
talking
always
about-
2 pin. Yeah.
From
Explain.
the trial and error method, we get to know that most of
okay,
the
sir.
cases terminal pins are working. In the output
Okay.
cases, the between two pins are not working, and in the input cases, both the terminal works finely, and the third pin, it sometimes works finely for the half adders. So it is a trial
So
and error. We have to check the pins are
okay,
working or not.
okay, so fine. I mean, you want to use the middle pins, okay? So let me try out a middle pin here. So suppose I am connecting it with this particular middle pin, okay? So now I want to check whether this is working correctly or not. So if I simulate, uh, suppose this is an half adder. So in this case, this is working, right? এটা কাজ করেছে. Okay, so you see this case. I mean, you see this is both the inputs are set to 0, but in this case, I mean, what is the output we are getting,
Yes, sir.
right?
Yes, sir. Yes, sir.
So I mean, see in this case, so again, I mean, if I am going to connect this one, so you connect this one, and now you simulate.
Better to follow the
You
convention whatever they have given instead of practicing.
I mean, yes, I mean, it is not in our hand. I mean, it's a
Yeah.
limitation that we have to use.
Okay, sir. Okay, sir. Okay, sir. Got it.
Simulator setting.
Well,
Sir, how do sir?
hello.
Sir, how do we
Yes,
delete a
or tell.
connection?
Just select a delete. Anindra, show.
Sorry, sir, what?
Delete the connection.
Repeat the connection.
How to delete a connection?
Delete.
Okay. Uh,
First select, then delete.
oh, okay. Just a
Connect.
minute. This is the connection. This is how you have to make a connection. So suppose you want to connect two ports. So what you have to do? Suppose delete this. So I mean, I am going to connect it with the primary input. So for primary input, you go to right hand side. Here you will see the input output option, and in input output option there is a bit switch. So click on it, single click. Then you have to click it here again. Okay. Next, you want to connect it with a wire. Go to this right hand side. In the selection tool, you will find connection. The second option, connection. Just click on it. Single time click, nothing more. Then come here, click again. First time click. Okay. And here you click again. And this is how your connection will be done.
Arpon clear?
Yes, sir.
Any questions from other side? Anyone? Whether you can connect it or not? The convention we follow to connect the circuit, you strictly follow it. Otherwise, simulator settings give some erroneous results. So, okay, two full adder circuit is show that for reverse gray about 2 bit.
So in this case, we can actually clone this particular full adder circuit. Go to clone tool and put it here. I mean, this is a little bit on the right side. Just a minute. Okay, Control Z is actually undo. It works here also. Okay. Put it here. So if we are going to use two full adders, so in a ripple carry adder, so what will be happening is that this is the sum and this is the carry. So my carry output will be the input of the second full adder, right? So what we are going to do is that we're going to remove this connection. To remove this connection, and this is the carry. Delete this. just to go to the connection here, connect it. Okay, so in this case what you will see is I am keeping this scene as 0. So suppose we give this value 1 and we can simulate this one. You see, I mean we're getting here 1 and final carry output is 0. Okay, so this is how you can actually start building a bigger, higher sized ripple carry adder. And what I have done here is that I have actually taken the carry output and I have placed it as the input of the second full adder. So here the connection is nothing different. All you have to do is just you go to the connection tool, you start here clicking, and then you come to this particular pin and just click it again. One thing I want to show is that there are actually two types of connection. Pictorially they actually show two types of connection. So if you click on this option, it will give you this type of pin diagram, this type of wire connection. So both of them you can use. You see, this is more like what you see in your books, and this is more like the wires connected in a breadboard. So in this way, I think you can continue your experiments, but you have to make sure that since when you are using the circuits that are actually provided by them for like full adder or half adder or whatever circuits, for example marks or anything, we always have to follow whatever the convention it works. So one thing I will tell you that since not many documentations are available, so if you are going to need any kind of circuits from here for building your own circuits, so try to first simulate this in a separate file. While simulate, when you find out that it is working properly, then only proceed, because otherwise you will make the connections but it will simply not work. Okay, so sir, hello.
Yes.
So sir, I mean for today I think we can.
Okay. So student, he has shown 2-bit RCA. So you have to continue up to 4-bit RCA. Okay. 4-bit
Sir,
RCA. 4-bit equal
sir,
to look ahead. Tell me. Yeah.
sir, one thing is that when they are submitting their assignments, so I don't know, sir, whether they are going to submit the logic file itself or a snapshot of the circuit running.
Snapshot.
Okay, so sir, they need to make sure that their user identification is visible here.
Yeah, visible in this case in the user identification, control current state, whatever you have seen, how to save the file. Yeah.
Sir, can you tell me like how to do the user identification again?
Okay. Okay. Just a minute. So I am in Linux, so I'm starting this. In Windows, you can just double click on the jar file and it will run the simulator. But in Ubuntu, you have to use the command. The command is given in their website. So suppose I have just built an AND gate. Okay, fine, and I want to save this particular file. So how the user identification will be available? So you have to save the file first. So you go to the save button, click it. Whenever you save, it will not allow you to directly save the file first. It will first ask for your name and roll number. So here you give your name and your roll number. Enter. Next you get your saving option. So I'm just saving this as an don't change the extension, it is .logic, the extension is. Save it. Once this is saved, now you go to this particular option, the last option, show user ID. Now you click on it, the user ID will appear here. Hello?
Yes, yes, sir.
Okay. Okay.
Yes.
Clear? I think the video is already recorded, so that you just follow audio and video or the recorded version, so you can get it again. Any issue, Rhythm?
No, sir. It's all right.
Any other question from our students? Students, any question? So this is the part for your report carry header, and you have to continue to carry look header and wall history. Wall history is the unseen assignment. That means you have to do yourself. If any issues, you can contact with us later. Okay. Anindon, now Hassan, Mahabub.
Sir, by when do we have to submit this, sir?
Hello?
I will give the link. Just wait, Mahabub. I will give the link to your Moodle, and there you have to submit. Okay.
Okay.
It
Sir,
may
we
be
have to open
Moodle
the
or it may be
report like
Microsoft Teams. Report header, carry look header, and wall history header. All these things will be mailed to you. The list of experiment. I think go to the site again, Anindon, and show the list of experiments.
Yes, sir.
See,
So this
that
is
list
the
and
list of
given.
instruments.
Okay.
Okay, sir.
Did you see it?
Yes, sir.
virtuallabs.iitkgb.ac.in/coa/hash. So automatically you'll get. Even you can search it, virtual lab on digital logic design plus IIT Kharagpur. You will find the website from their post also. Clear?
Yes, sir.
Apart from that, any question for students? With this? Also, tell me.
Sir, should the adder be of 4 bit?
Up to 4 bit, just you do 4 bit. Only one circuit. 4 bit for equal carry header, 4 bit for carry look header, 4 bit for wall history header. If the circuit becomes very high, I have to show at least in the simulator you can easily you can draw. Just minimize the free blank space among the chips and lines, so you automatically you can draw. Okay.
Okay, sir. Thank you.
And Mahabub, now would you like to show the marks?
No, sir. I think, sir, I'll show it next day.
Tomorrow.
I'm facing some
Okay,
problems with it.
next issue, no issue. So today, up to this, we are finishing the classes here regarding this simulator. If any question regarding this simulator class?
So, for the
Yes.
carry look ahead adder and wall history adder, we have seen that there is already that adders we have. So, can we
Yeah.
use them or should we do from using full adders and the basic circuits?
No, all full adder. All everything you have to. Very good questions from Bonali's side. So all you have to implement using full adders. I would like to see the propagation of the carry and not directly that you use this circuit here. Okay.
Okay, sir. Okay, sir. Thank you.
Internal inside the circuit I have to implement. But sometimes it happens that your full adder is required to make a sequential adder. Okay, that time you can use that full adder directly there instead of implementing the full adder here. When I will ask the question, implement a full adder using a 2 half adder, that means you have to show the logic of the half adder and implement the full adder. Okay. Actually, we have to implement AND or logic, universal logic, De Morgan's theory, all these things we skip due to the time limitation. Only directly we are implementing ripple carry adder. Okay. You can practice by yourself with the home different fundamental logic like De Morgan's theory, whether it is implementable or not. All these things try to implement from your side and at home also to get acquainted with the software. Okay. So this is the link of the software. So you can get it from here. Also, there is a workshop. You click in workshop. Anindam, click workshop.
Yes, sir.
Click on the workshop. In the
Yes, sir. This is the
workshop
workshop page. So
workshop,
manual sheets are
there is a
available.
manual. Yeah, manuals are there, and also the experimental slides are there. Okay. You will find lab manuals and presentation slides. Did you see lab manual sheet for presentation PPT and PDF? You just see it and get the view of the simulator. How does it work? Okay. Any question?
We download Mars also.
Yeah, Mars. Mars, I think our another teaching assistant, Mahabu Hassan Hala, will explain you regarding the Mars details. Okay. There another software Mars is required. Even though using this software also implement the same mapping function as well as the Mars also. So next class we will continue directly flip-flop synthesis and its implementation of counter register. So we will not get sufficient time to implement all these things. I know before the exam, your exam will be little bit postponed. You can understand it. So automatically you can get the sufficient time within April. So try to finish it as possible. And also, Oninon, click on the experiments. So in the last two assignment, particularly Karnaugh map and point McCloskey algorithm, I told that using any programming language, you try to implement the program. Point McCloskey, any doubts you have?
No, sir.
I think this algorithm already we discussed earlier in the digital logic class, so you can directly jot down it. Okay, so I am just correcting your attendance. It's over. So if you have no question, then you can leave the class.